Hello all, my name is Mikala Vashit Reddy, pursuing my BTech at Institute of Aeronautical Engineering at Bachelor of Computer Science of Artificial Intelligence and Machine Learning branch. Today we are going to be discussing about real-time face tracking based on a Kalman filter. So usually when in technologies like face biometrics, the systems are not always efficient when faced with a moving image or a blurry image, or we can say foggy or any image which is not stable is subjected to either wrong classification of the image, or we can say an image which is being subjected as undetermined, which is both not useful for the model, and in fact it creates a bit of ambiguity for model to even classify such images. So we are going to be discussing in this present how Kalman filters are working in this situation, and how exactly Kalman filters help a model in determining the faces even though the frames are moving from one place to other for every variable or constant time. Advanced security systems that can track and recognize multiple individuals in real time are essential for monitoring large areas effectively. Ideally, such systems would use accurate face recognition to identify people and log their movements. However, current methods face challenges with larger datasets, varying lighting, and pose changes. Traditional approaches combined Kalman filters with basic face template matching and secondary check like clothing similarity to distinguish individuals, but these are not suitable for real-time applications due to complex and assumptions. So here we can see basic comprehensive workflow of the how a face tracking system works. It starts by a raw image where the model has to decide if it is a face or not. Usually, when a biometric system is faced with a person standing near it, it has to classify out of all the objects in the captured by the camera what is face. So this can be simplified using a media pipe model, or we can simply use a convolutional model, which is usually a traditional way. Either way, usually this face recognition is done by accessing the generic face database and comparing the features of the image to database, ultimately finding the appropriate feature details matching in the database. Now, usually what happens is when this model does not predict or classify a person in one shot. No, because every time a face recognizer gets the same feature details in the database, it might be wrong because he might be moving, which can trigger a sense of unrecognizability for the model. This is where Kalman's filter works. Here you can see if initially the frames are moving, if the model does not match any of the database details, it will create a new Kalman filter where Kalman using Kalman filters face details are being predicted by changing frame movements, ultimately updating the Kalman filter track, and now checking this using this new tracking details. Once again, the database is being checked where if not Again, the process continues if the model fails to identify the face. If not, the image is being carried out to user interface with a simplified complexity of data being transferred to users to display. Multiple face tracking systems being begins by capturing a frame from a live stream videos where HAR-based face detection is applied to identify facial regions. Detected faces are then analyzed by a low level recognition system to extract features, which are compared with existing trackers to find similarity scores. If a face matches on an existing tracker based on threshold, the tracker is updated. Otherwise, a new tracker is created. Kalman predictions is applied to uh, trackers that wasn't updated, allowing for continued tracking despite occlusions or post changes. Duplicate trackers are then removed. The Kalman tracker works by estimating and predicting the face's position and size using past and present data. It operates through two key processes: when a face is detected and when face is not detected. The tracker state vector includes face position, velocity, velocity and width, and uses a find to find transition matrix to predict future states. Here you might be asking where this find to find transition matrix came from. Usually, to identify a particular phase, the frames. So to paste down the moving frames, we use a HAR-based image processing technique to extract the stable frames, and then usually these HAR-based equations uh, have 5 into 5 transition matrix where Kalman trackers use this HAR-based matrix to its advantage and form a 5 into 5 transition matrix. Kalman filters update the tracker state using measured face position and size. With Kalman gain adjusting based on tracking the error, each tracking represents a unique person and stores their name, facial features, and current state, and time since the last update was done. And here you can see how HAR-based matrix is used in Kalman's filter, where using the projection function of Kalman filter, we are going to get this equation, which is a quadratic complexual matrix with KT representing the Kalman factor and X1, Y1, and W1 representing the unique facial classification features. This is the HAR values and the projection function here of the facial features. The Kalman Face Tracker provides a fast and reliable means to continuously locate the faces in individual video frames. The tracking systems is then used to support a higher level face recognition system containing a database of large number of individuals. By tracking the faces in the scene, the face recognition system can perform multiple tests on an unknown face to provide more reliable results in separate activity, permitting it to be computationally expensive while still maintaining the real-time ability of overall system. In this paper, the feature extraction for face recognition is performed using an adaptively weighted modular principle. Each tracker, so talking about the experimental results, each tracker in systems represents a unique individual It maintains a state vector containing the face's position, velocity, and size, which helps in forecasting future movements. Additionally, the tracker shows the person's recognized name, allowing for consistent identification over time. Facial feature vectors are also retained for comparing incoming detections and maintaining accuracy associations. The system keeps track of time elapsed since the last moment update for each tracker. As you can see the results graph are being plotted against a correlation coefficient factor and number of frames being captured, and also correlation coefficient and frame captured using a correlation template. And here we can see a clear picture of how a Kalman filter works. Here we have three facial figures where each facial figure is moving in BCDE frames, where with each movement of frame being moved, being plotted in x-axis, and how actually Kalman filters plotted the movement and classified a particular person. So, in this presentation, we have shown a face tracking system capable of predicting the movements of multiple people based on a low level matching system. The tracker distinguishes between multiple faces by generating feature vectors obtaining from principal components of a generic facial database. This method was shown to prove basic classification through a correlation metric, which is needed to perform multiple face tracking. So thank you guys for sticking with me in this presentation. I hope you to see in the next video.